Comes on everyone. Hope everyone has tried this homework problem. The first one was easy. Everyone got that. The second one is an interesting one. Sure, let's see. The first one. So if you look at this component here, this vertical component will be u cos theta. The horizontal component will be a ball, no? Why am I writing this? Yeah, first one is right, Abhinav. So if you look at the components here, this would be theta. This is u cos theta. This is u sin theta. So after collision, the horizontal component will remain same. And the vertical component will become E times EU cos theta. Na? Remember, only the component along the normal will change. The horizontal component will not get affected. So this is velocity V. This is angle phi. So from here we get tan phi is U sin theta by EU cos theta. Basically, only the component along the normal gets affected. So 1 by E tan theta, the speed V will be root over U square sin square theta E square U square cos square theta. That's your speed. Clear? That's your velocity and that's your this thing. You could have written like this also. V sin phi should be equal to U sin theta, isn't it? The horizontal component is same. You could have written in terms of phi, or you could have just squared them and added them. It would have worked. Clear, everyone? The second part, this is a good one, right? So this is theta. This is during collision. This is after collision. So if you resolve this into components, you end up with U cos theta, U sin theta. I will write this thing as Vy. I'll write this thing as Vx. And during collision, the forces will be normal reaction. And if remember, both are impulsive. You can't conserve linear momentum here if there are impulsive forces. Now, this thing goes out of the algo actually, meaning we still use force and force equations, but we use the more raw form of what you call second law. The raw form of second law is what? F is dp by dt. Basically, impulse-based problems. So first thing, if you try to write impulse in the vertical direction, integral n dt, again, don't get scared of the integral. We don't use it. But integral n dt is the impulse due to the normal reaction is change in momentum in the vertical direction, which is nothing but m v final, that is Vy, minus minus mu cos theta. And here I know V final. How much is Vy? Eu cos theta, right?
You got it. Yeah.
If you hit a wall with speed u, you'll bounce back with Eu cos theta. So vertical will not get affected because of horizontal friction. So integral n dt will be mu cos theta 1 plus e. I don't know n, I don't know dt, but I know what is integral n dt. So in the horizontal direction, minus friction dt, minus because it is on the left hand side, is change in momentum in the horizontal direction. This would be mvx minus mu sine theta. This would be mu n dt is mvx mu sine theta. But I know n dt is mu cos theta 1 plus e. So Vx would be u sine theta minus mu u cos theta 1 plus e. That's your answer. But like again, whenever there's a friction, there is always a catch. This is valid only if Vx is greater than 0. Think about it. If Vx is negative, you know what you're saying? If Vx is negative, the ball goes like this and bounces like this. Does it even make sense? So that case is not possible. So let's see what is going wrong again. So if Vx comes negative, remember we have assumed this is maximum. Actually, that is always maximum, but there is another reason I'll tell you here. But have a look at this page. This is how you handle these kind of problems. Please have a look at this page. Clear? Now, the u sine theta minus mu cos theta 1 plus e. So this is valid if Vx is greater than 0. If Vx is less than 0, this implies the friction stopped acting somewhere in the middle. Stopped acting when Vx became equal. Tell me one thing. Why friction acting in the first place? Because there's a horizontal velocity. The friction is trying to stop that, isn't it? But if Vx becomes 0, why should the friction act? Getting it? So during collision, if Vx becomes 0, then Vx is equal to 0 during the middle of the collision. So let's say the total collision happens for 2 milliseconds and the horizontal component became 0 in 1.5 milliseconds. So friction will stop acting there. So the actually equation, right, becomes like this. So integral n dt is mu cos theta 1 plus e. Dt is the full time of collision. The friction is acting maximum because it is slipping, but it is not acting for the full time. It is acting only for some time. Dt dash is the time for which friction acts. So dt dash is less than equal to dt. You're getting the logic there? There is a possibility during the collision, friction is so strong, it made Vx 0. If Vx becomes 0, then there's no need for friction to act. That means you cannot write this thing as F into dt because friction is not there after dt dash. So if Vx is 0, that means what? Therefore, the body Vx is 0. So if we get Vx is 0, Vx is less than 0, it means there is no horizontal component. That is, Vx actually became 0. So that happens for a very specific case. So if you put Vx less than equal to 0, this guy would be u will cancel. Tan theta is less than equal to mu into 1 plus e. That is the condition there. So this is what would happen. The ball will come with speed u. It goes pretty interestingly. Hits the floor and bounces off vertically. There's only Vy, there's no Vx. You're getting? The ball will go like this. This is the case. So there is a rare case this can happen like this. The ball will hit the floor and goes vertically up. It can never come back. Clear? This happens when the tan theta is less than equal to mu into 1 plus e. This second part is the most important thing. What if Vx is less than 0? Some people even figure out till here, but then they don't realize Vx can't be negative. If Vx came negative, it implies you have the friction actually stopped acting at dt dash, but you thought friction was acting for dt and you solved. Means friction continued to act even when Vx became 0.
Yeah, so when Vx becomes 0, it bounces off normally to the side.
Vertical. Meaning,
No, it like bounces off vertically and goes straight up, right?
yeah, Vy is still there, na? Only Vx is becoming 0. Clear, everyone?
Then why wouldn't it come back down?
Would come back. अभी तक इतना story क्या था, boss? Last 10 minutes, I'm shouting that only. You're asking me that. Why do you think it'll come back? You tell me.
The gravity?
Come back meaning what? You're saying coming back down?
Yeah.
That too will come back. Why don't come back? Arre
Ah,
God, come back meaning I mean this thing. Back, left
oh, okay,
side.
okay, okay. Okay.
That's what I was thinking. Why are you asking that? Why it won't come back? It'll come back. It'll go up and come back. उसका कुछ problem नहीं है. Here I meant back meaning left side.
Ah, that I understood.
That you got it, na? Should have said, sir, why won't it come down? I would have understood better. Maybe I should have said it won't go left. My mistake also. Clear? It's a good question. 48B part. Getting it? It's a different model though. Next thing. A ball collides with a wall with U bar, which is 3I minus 4J. And bounces with 2I plus J. Find quotient restitution. Where is the wall? Nothing is given. Only the initial velocity of the wall and the final velocity of the ball are given. Find restitution. It's a good one. This will be again proper advanced single choice question. Question looks innocent. It's not. I have a brilliant idea. Tell me what you think. I know whenever you hit a wall, the speed becomes u cos theta. So I will find mod u, which is 5, and mod v is root 5. So I can write v is equal to e times u. So root 5 is e times 5, and e is equal to 1 by root 5. What do you think? What do you guys think? It's a good idea, right? Right, wrong. I know somewhere, it is not right. Itna to figure out kar liya. Now why it is wrong? We don't know theta, wall may be inclined, we can't assume what to be equal.
फिर वो जो वेलोसिटी के कंपोनेंट्स दिख रहे हैं उसके हिसाब से बॉल ऐसे आ रहा है और फिर ऐसे जा रहा है. That means the wall is nature.
That is fine. मतलब point क्या है ना? This thing is hitting and going like this ना. How can you say full speed becomes e times u? Only the component along the normal will become e times u. Got it? So here the mistake I am doing is I took full speed u, final speed v, and I said this u is equal to e times. This is a blunder, right? So if I'm sure it is hitting the wall normally, then I can do this. कोई guarantee नहीं है. You didn't tell me anything about the wall. Okay, Lakshika, you got an answer. Let's see. I don't know whether it is. Might be right. I don't know. Others, what do you guys think? Aryan, let's look at your answer. It's a big blunder. Now, this is what I'm saying. It's okay if you don't get right answers. This is very important thing, everyone. Listen. Not only this thing, see, this is a skill. When you're writing exams, right, you get some answers. You should know sometimes that you can't figure out it is right. But once your subject develops to an extent, right, you start thinking, yours is a blunder. So if you get an answer 68 by 12, can someone tell me why it is a blunder? I'm not even saying wrong, blunder. Wrong alag hota hai. Wrong meaning it is within the theoretical acceptable range, but it is something messed up.
Greater than 1 or
Greater than 1, not acceptable. There. So that's what I'm saying. Learn, it is very important skill. It's okay if you don't know what is right and wrong, but you should know when it is not a blunder. Quite an important skill in life. Most of the times, right, you don't know what is right and wrong, but at least make sure you don't do blunders in life. It's like tomorrow, right? Should I choose mechanical engineering? Should I take electrical engineering? Should I go to IIT Bombay for better branch? Should I go to IIT Delhi? Now, this is nothing right and wrong. It is just choices, right? Should I do drugs? Should I not do drugs? This is a blunder. Here, there is no choice. Getting it, should I beat someone? Should I not beat someone? So the thing is that never touch bad things. So at least know in life, boss, ye blunder. Don't even get close to it. So quite important, you should know what are bad things in life and don't even go there. If you see most people engineering, that's how they start drinking. Some idiot friend will come and say, "But try kar dekhna." And these people, right, don't know, na kids. They think like, क्या होगा एक बार try करने से? एक बार से it won't stop. Always be careful. Whenever someone tries to put a bad habit, first thing, run away from there. It starts like that only. Once it's okay, everyone is doing. These are all bullshit things people say. You are not that person. You have much higher moral values, so you behave that way. It could be anything. कल exam है and today all friends decided to go out and play turf में. You know that is a wrong thing. कल exam में कुछ preparation नहीं हुआ. How the hell can you go and play? People will say this guy is a nerd. He's going and playing. Let them think ना boss. कल जब IIT जाओगे and these people join some Don Bosco Engineering College, then they'll realize. Let's see how to do this thing. So the idea main here is, so it's a very important skill knowing what is blunders in life. I'll give you one more example. Bank, you know, it's like you see a poster somewhere or an advertisement comes. Give the monies to us. We will double the money in 3 months. The bank, SBI Bank will say, give the money. We will give you 6% interest per year. Can you see the blunder? To figure out blunders in life, that is more easy. That's it. If you don't do blunders in life, you'll do much well in life. So this is somewhere the normal. So the catch here is the force will act along the line of impact of common normal. Since force is along common normal, the change in velocity is also along normal. Do you agree? Why? Force is dv by dt. So change in velocity and force should be parallel. Therefore, delta v bar is parallel to normal vector. Got it? So delta v bar is v final minus v initial 2 minus 3 minus I cap, j minus or minus 5 j cap. So if you take a n cap, so if you take a parallel unit vector, this would be minus I 5j by root 26. This is your unit vector. So this is your u bar, this is your v bar, this is theta, and this is phi. And I hope you remember a bar dot b bar is mod a mod b cos theta. So if you want a cos theta, that is nothing but a bar dot b bar by mod b. This is how you find the component of one vector along another vector. So u cos theta will be u bar dot n cap by mod n cap. V cos phi is v bar dot n cap by mod n cap. Coefficient of restitution is v cos phi by u cos theta, which is v bar dot n cap by u bar dot n cap. V bar dot n cap is v bar is 2i plus j. U bar is 3i minus 4j. So v dot n will be minus 2 plus 5 by minus 3 minus 20. Put a mod 3 by 23. Yeah. Anusha, you got it right. Lakshika, you also got it right. There we have 2 answers, everyone. Please check the steps. So the main idea in the question is first try and change in velocity. That will be the direction of the normal vector. So then resolve the components of initial velocity, final velocity along the normal and divide them. That is the problem, na? You didn't know the normal vector. You want what you're interested is the components along the normal. You don't want full velocity. First time you're using this thing, components of one vector along another vector. We learned it, but we never actually used it in any problem before. Actually, we did use reoptics in reflection. This is the second time. Clear? Question looks simple, but it is really not that simple. It is little deadly only. It's a worthy question, single choice advanced. Next one. Any doubts on this? Clear? I equated the perpendicular components and then found tan theta. How did you get the perpendicular components? Are Anusha? Just unmute and tell her.
Sir, I actually assumed an angle theta and then I took the components along theta and then I took whatever was parallel to the wall and equated those components. So I got tan theta from there.
Yeah, but meaning
I
first you
assumed
found
an
this
angle
thing.
theta of the wall, yeah.
Okay.
And then I equated the components along the parallel.
Okay.
And then we already know the U and V vectors, right? So if I equated them, then I
एक
got
बार
an
वर्किंग भेजो
equation.
ना,
So,
वर्किंग भेजो, मैं देखता हूँ.
alright.
भेजो बाद में ना, once you wrote that, just send it to me. I'll see. Maybe it might be right, but मुझे strike नहीं हो रहा. How did you assume करके? Send me the working. Once I see, I'll get an idea. But you got the same answer.
Yeah.
Maybe. Clear with this? Next one. But which one had more steps? My method or your method?
So my method had I guess 2 or 3 steps. I'll just take a photo
भेजो.
and
Let's
send
see.
it to you.
Maybe if maybe if ours is good, so we will use that only next time. Nothing wrong. ऐसा कुछ नहीं है. Every time my method will be easier. Next one. We are projected with speed u, theta. There is a wall here, E and D. So this ball goes there, hits the wall at H max. After hitting the wall, it falls on the ground and then it bounces and goes back to the point of projection. You getting how's the scenario? So a ball hits the wall at H max. Falls on the floor. And bounces back to the point of projection. Find D. Let's get that. Question is clear? This happens only for a particular value of E. Malika, clear so far? Swastika, question is clear? We have done almost 50 problems, everyone. You guys should resolve the entire notes once again today or tomorrow. I'm telling you again, do the class notes ka problems once or twice properly. If you understood these things, you'll be able to handle most of it. Don't run behind doing 10 different things. Just stick to your classes ka booklet, class notes, maybe one more booklet, or you can do Eridoka questions which I gave. And I'll start posting, some additional questions in the group maybe from 1 or 2 weeks ke baad se. Every week I'll just post 3-4 questions additional, like some tough ones to solve. How do we do this? I'll give you a minute more. We have one answer. Anusha, what made you think it'll go both are perpendicular? Who told you U bar and V bar are perpendicular? But those angles कैसा आया then? When you took it vertical, how do you take theta? You took that parallel to the incline, na? No? Okay. Okay, I got your point. It's not perpendicular. You just took a line and you said that. चलो क्लास के बाद डिस्कस करते हैं. Any answers? We have one answer for this. Adrit, Aryan answers. Abhinav, Aditya, Rehan, Itza.
Sir, I'm typing.
कुछ ही इतना नहीं आंसर, छोटा आंसर है टाइप करने के लिए. कितना बार कर रहे हो? If you type it is just like 2 digits का आंसर. चल टाइप कर लो. Comfortably type big answer, it's okay. Astika, Maulika, Anika, answers, anything? Udayan. Let's see, at the H max, when you hit it, what is the speed?
2 cos
It'll be wrong then. Adrit, type करो ना रे Adrit, it's okay ना. मैं ऐसा बोल रहा हूँ, like you can type ना, maximum it will be wrong. Big deal. क्या बात है? It might be right. And maybe I'm just scaring you guys not to give the right answer. You know, na, physics teachers are generally evil. Let's see. So when you project with u and theta, you go there. Since you said you're hitting at h max, this speed will be u cos theta. If you hit a wall with u cos theta, you'll bounce back with u cos theta. Now, since it is h max here, this distance will be r by 2, half of the range. Everyone agrees till here? So if you go with u cos theta, you traveled r by 2. If you travel with eu cos theta, you will travel e times r by 2 because the speed has become e times. Agreed with this statement? If your speed has become e times, then the range will become e times because the time of flight is same, root 2h by g. The time of flight will not will be independent of the velocity, the same height. So now when you hit the ground, this is what happens. See, when you are hitting the ground, this thing has two components here. One is eu cos theta. The vertical component will be u sin theta. If you go up with u sin theta, you will come back with u sin theta. So after bouncing here, now see what happens here. Only the horizontal component will remain same. The vertical component will become e times u sin theta. Only the velocity along the normal will change. So when you hit the wall, horizontal component will become e times. When you hit the floor, the vertical component becomes e times. So this guy looks like a projectile with eu sin theta, horizontally eu cos theta. So this will go here and fall somewhere here. So time of flight is 2 times v vertical by g, 2 eu sin theta by g. The range will be ux into time of flight. This is a more general formula that u square sin theta I think came from there. That is definitely wrong. देखो ना तेरे dimensions match हो रहे हैं क्या? That's what I keep telling you. When your answers have blunders, at least you should do a blunder. है. You wrote 1 plus 16 u square by g. चलो लिख लिया जो भी है. This thing has the dimensions of height. This is dimensionless quantity. How do you add them? Got my point? That see, it didn't even take me more than a second. You know, I saw and I know it is wrong. Trust me, this is a very important skill. This way you can eliminate a lot of options in the exam, saves you a lot of time, and gives you confidence when you see a paper, especially exams like BITS or CET, even mains also you'll be able to guess. So this would be EU cos theta. Time of flight is 2 EU sin theta by G. So this would be E square, U square, sin 2 theta by G. This would be E square R. And that means after hitting the ground, this guy will bounce off and come back again, and this will be E square R. So from here we can clearly see E square R plus ER by 2 should be equal to R by 2. R gets cancelled. 2E square plus 2E minus 1 is equal to 0. I know the answer already. So E is minus 1 or E is equal to half. You can't get minus 1, so E is equal to half. Please check the steps. Yeah, even I get quadratic in E, but independent of U I get. The answer is independent of U and theta. Please look at the steps.
Sir, वो quadratic
Hmm.
E 2E square plus E minus 1.
ये होगा, ये होगा. Yeah. Like I said, I know the answer, so I wrote it down. I did this yesterday only. Clear? Easy? Good one? Projectile? And again, collisions. Next one. Adrit, found out where you messed up. Others got this thing. Did everyone figure out at least till here? You should have figured out at least till that part. That when you fall back, you're falling ER/2. That much should have figured that out. चलो उसके बाद click नहीं हुआ. I can understand. Next one. Top view.
So can you go back for a minute? Yes, sir. Thank you.
We have a coin here. 3m radius r. Speed u. mr. I'm sure you must have seen something like this during carrom board. mr. Find the velocities after collision. Coefficient of distribution is equal to half. Find velocities after collision. Three u/4 for which one? There are three balls here, right? If you see, this is a different one from what we did. Till now, we did all problems where only two things were colliding. Here, there are three things to collide at the same time. This 3m will hit both of them at the same time. This will be slightly different from what we did. But remember, the distribution is only written for two bodies at a time. You can't write for all three. The two m balls velocities are 3u/2. Let's see. I don't remember. I don't know the answer for this. I just gave some random numbers. So let's see. But I don't think that is right, Aryan. I'm not sure. Could be right also. 3m ka velocity nikalo. You need to find this velocity of 3m also and m also after collision. Just give it a try and get some water and come. Okay, we have some velocities. Minus 2 by 3u, 3 by 2u. Okay, let's see. First thing, I keep saying every time, whenever you see collisions, the first thing, to always draw the final diagram. So before that, you have to, so when you join them here, since all have same radius, they'll form an equilateral triangle. I think you guys might be right. Most of you are getting similar answer. This is an equilateral triangle. So if this is velocity u, this would be 30. Now after collision, just after collision, the 3m is going with v1. This guy is going with v2. This guy is going with v2. How do I know they're going that way? Since the force is along the common normal, the velocity has to be along the common normal. Isn't it? There is no way that two m balls can go in some other direction. Since the force is along the line of impact or the normal, the velocities have to be along the normal for the 2m's. And by symmetry, we can see 3m, the force n and n, right? By symmetry, the resultant is horizontal. Therefore, 3m ka velocity is also horizontal. Since force is along normal, the ball m will go along the normal. This is the first thing, the diagram. Hope you guys did that thing. Then conservation of momentum. I hope everyone is clear why v2 should be in that direction only, not any other direction. Since initially m was at rest, and if you kick it in some direction, the velocity should be in that direction. So initial momentum is 3mu. The final is 3mv1 plus mv2. Remember, this angle was 30 and this angle was 30. mv2 cos 30 plus mv2 cos 30. And gets cancelled. 3u, 3v1 plus v2 root 3. This is equation 1. Now, when you write coefficient of restitution, remember, this E is equal to when you write v2 bar minus v1 bar by u1 bar minus u2 bar. These are velocities along the normal. These are not full velocities. These are velocities along normal. So just choose any two balls here. So I will choose here 3m and m. So 3m is going with u. Initially m is at rest. This was the normal you had to take. So this component is u cos 30. So E will be V2 is V2 only. V1 will be V1 cos 30 by U2 is 0, U1 minus U2. So U1 is U cos 30. This is equal to half. So V2 minus V1 cos 30 is equal to U cos 30 by 2. So from here I get V2. V1 root 3 by 2. U root 3 by 4. This is equation 2. Take this guy and put it in this. Check the equations first. I conserved momentum in the horizontal direction. I wrote restitution for 3m and m. Reason being simple. Whatever you write for this, it will be the same for this guy also. It won't matter. Since it is a symmetrical, if you can just write for 3m and m for the upper ball, the lower also will be the same equation. Please check the equations. 4 by 5. So once you got this equation, now it is just a matter of solving. If I put it there, I'll turn the page. 3u is 3v1 plus. This is bad. v2 is v1 root 3 by 2 plus u root 3 by 4 into root 3. This is 3u, 3v1, 3v1 by 2 plus 3u by 4. 3 cancels everywhere. That will be u minus u by 4. It will be v1 plus v1 by 2. 3u by 4 is equal to 3v1 by 2. v1 is u by 2. Interesting. And v2 will be, just dump it here. U root 3 by 2. U by 2 na, u root 3 by 4, u root 3 by 2. Can't we directly conserve momentum without taking it in a particular direction? Okay, then what will you get? You need to understand this ball will, then the problem will be what? Then this will be a vector quantities, right? What will you do with the vertical components then? You can't choose v2 will be this way, isn't it? Please check the equations. And I got these answers, which look suspiciously very good numbers. I didn't expect this. I goofed up somewhere, or anyone got the same. I think someone did get the same. Swastika, you did get u32 by u. Aryan, you also got the same. Yasha, you got an extra 3. I think some people did get. But check the equations. If you got the equations, calculations, I know you can do. As long as equation 1 and 2 are right, we are right. Solving part, I trust you guys. But the steps are clear. This question still makes your life easy. Can you tell me how will you do something like this one? What if I give a scenario like this? We'll not do it. It's complex, but I just want to know, like, how will you follow with this? Let's say the upper ball is E is equal to half, the lower ball is E is equal to 1 by 3. I can just mess up the masses, everything I can mess up. What changes? Just tell me what the basic steps, meaning no equation, nothing. How will you do this? How will you proceed? Just take a minute, think about it. Then I'll show you and tell me whether you thought the same thing. Remember one thing, advance mein, when you see a question, within first 20-25 seconds, you should know what to do with the question. First 20-25 seconds, we should know what to do with the question. Ye question mein ye hoga, then I should do this. The plan should be ready in 20-25 seconds. Then solving will take another 3-4 minutes. Advanced papers are going to be lengthy. But if it takes you only 2 minutes to figure out what the hell is happening with the question, then you won't be able to solve in given time. If there are 20 questions in advance, the target should be at least to solve 16, 17. Usme 2-3 can go wrong. So at least 14, 15 are right. And the way the papers are coming last 3 years, physics papers are manageable papers, but they take solid 1 hour time to solve. That's what all of you seniors told the same thing. It's a paper I could do if I had 10 more minutes more. You'll never get that 10 more minutes. See, the final diagram will look like this. Because the final exam, the one thing which will mess up is your max paper only. That is going to eat away all your time.
So every year maths is only tough.
पता नहीं क्यों they are doing this from last 3 years. So under that assumption, no, it is not about max stuff. I'll tell you what happens. See, if you see in top 4-5,000 ranks, right, most of the people ka favorite subject is physics. Most people ka favorite subject is physics. One thing, maybe subject is intuitive. Second, physics, you know, what happens, I'll tell you. End mein, right, I'll give you 100 questions and I will revise almost 95% of the portion in physics. I can do that for physics. You can't do this for maths and chemistry. If you have 10 hours to study every day, you know, normally how people study? They study 4 hours maths, 4 hours chemistry, and 2 hours physics. Sufficient. That way, physics is easy to revise and easy to solve, because if you do one problem, I give 4 chapters in that one problem, isn't it? So physics that way, right? People love it. Intuitive. मतलब वो click हो गया तो question click हो गया. So most people will do physics. And सबको पता है chemistry में organic inorganic रट्टा मारना है. So people will do chemistry. So if you do your physics chemistry well, and if you do max average, you can push your rank up to 1,000, 2,000. But if you want to enter into the top 2,000, max is the deciding factor. So physics to kitna bhi paper tough though, I have observed people still do it. So first, because people ka favorite subject hai na, they take it on their ego and they solve questions. For some reason, max, I don't know. So that is why reason we say max is a deciding factor for top 1,000 ranks. But without physics chemistry, you won't even enter the 3,000. So that is one thing. Chemistry should be definitely everyone should do. Currently, that's what we are facing with some of your seniors. I told you, I think last time, there's one idiot who scored 95 maths, 95 physics, I think 61 in chemistry. 61 bhi nahi hai, 37 hai, I guess. 37 in chemistry. Literally, I had to scold him every day for doing chemistry. So uska work by every day 4 hours chemistry is studying now. Let's see. So here, this is the catch here. So this guy will have a velocity v1. This guy will have a velocity v3. Let's say v1, v2. This guy will be v3. Got it? So we have to write the momentum in vertical direction, horizontal direction. That will be 2 equations. Momentum in vertical, momentum in horizontal. How many variables are there? V1, V2, V3. 3 variables are there. Since I took the masses are same. This is also a mistake. See, this is V3x. This will be V3y. There's no guarantee 3m will go horizontal, no? Because the masses are different, these normal reactions will be different now. This will be N1, this will be N2. So you have 4 variables. Now the 3m also will go in some weird direction. Momentum in horizontal, so this is equation 1, equation 2. Then you write restitution for 3m and 2m. And you write restitution for 3m and m. 4 equations, 4 unknowns. You solve and you'll get the answer. It will be very lengthy one. You can do it, but lengthy. Check this out. Yeah. Next thing. So that is about collisions. The next thing is a variable mass systems. Now in variable systems, we have rocket propulsion, that is one. But before that also we have some other varieties. So let's see them. The first thing is chain-based problems. Let's say we have a heap of chain. Heap matlab it's a this thing collection. And someone is pulling it out with speed u. F. Lambda is the linear density. That is mass per unit length. So the chain is pulled out of the heap with constant speed u. Find F. The chain is pulled out by force F with constant speed u. Let's get this. I have an idea here. Since I know acceleration is dv by dt, since it is constant, it is 0, and I know F is equal to ma, so force should be 0. What do you think? Boy, what is the problem? It is such a beautiful solution. Y'all are just jealous that I got the answer easily. What do you guys think? Mass is not constant. You can't use F is equal to ma. F is equal to ma is valid only when mass of the system is constant. Here, when you pull the chain out, more and more mass is coming out. Mass is variable. So we can't use this. So how do we do this kind of questions? Take a small piece here, dx. So dm will be lambda into dx. So change in momentum will be dm into speed v. We know force is equal to rate of change of momentum. This is always valid. Mass is there, mass is not there. So this will be dm u by dt. You could have also said this way. F is dp by dt, which is dmu by dt, product rule. The force is actually m du by dt plus u dm by dt. So generally mass is constant, so that term becomes 0. So in this term is 0. The second term is not. So F is dm by u by dt. So this would be lambda dx by dt into u, which is lambda into u square. So if you want to pull the chain out of the heap, you need to exert a force of lambda u square. Vice versa, think of like this. If you're pulling with F, the heap is pulling the chain backward with lambda u square. This is the force on the chain due to the heap. See, every time you pull out, you're creating a momentum for a small mass, which is at rest to speed you. So who is giving that momentum? This force. So this is the force on the chain due to heap. So if you want to pull the chain out of the heap, you need to exert this much force lambda u square. Check it out. Easy? Clear? Next one, turning the page. Same question, but this time someone is pulling the chain vertically up. Chain is pulled vertically with constant speed u. Speed is constant. Find the power due to the force as function of x. Gravity is there. X is the chain that is removed from the heap. So you're pulling the chain vertically up from the heap. So find the power due to the force. as function of x. So if you draw FBD of this chain, so you're pulling F, the chain ka own weight mg, which is lambda xg. And remember, whenever you want to pull the chain out of the heap, you have to give lambda u square. This is always there. This is the thing people forget. That to pull the chain out of the heap, you have to give, the heap will pull you back with lambda u square. This we did in the previous thing. So this can be written as now. So this force is lambda xg plus lambda u square. So there are two components of the force. One is to balance the weight. Since you're pulling with constant speed, it does not accelerate. And one is the force due to the heap. Yeah, power is F into V. Lambda xu plus lambda u cube. Check it out. Right, Adrit? Easy. So the main thing is that you should know that the lambda u square part. Clear? Let's see one more. Any doubt so far? Neil, Rehan, clear so far, na? Utsa, Vartika, got this? Palaksh, clear? Great. Next one. Chain only, another type. We have a chain which is held vertically, just touching the floor. It is held vertically touching the floor. So when released, the chain hits the floor and slides to the side. And diagram would become like this. The chain is hitting and sliding to the side. Gravity is there. Find the force on the floor due to the chain as function of x.
Sir, can you show the previous sum for just a second? Yes, sir, thank you.
Let's get this. So if you think about it, the more the chain falls, won't the speed be more? The chain is actually hitting harder and harder every time it hits the floor. Try, you got 2 minutes. So when this is x, that means the chain has fallen how much? X, isn't it? That means the speed of this chain will be root over 2gx. Because it's in a free fall, the acceleration will be constant. So when this thing hits the floor, so dx, the change in momentum will be lambda dx into v. So f will be dp by dt, which is lambda dx by dt into velocity, which is lambda v square, which is 2 lambda gx. This is force on the floor due to the collision. And this will be there in the option. I didn't ask you this. The question was find the force due to the chain on the floor. So the most common thing that people forget is there's already some chain sitting on the floor. So that will be normal reaction, and that will have its own weight, which is lambda x. So this force will be force on the floor due to the chain which is at rest. Both are due to chain only. Due to the chain which came to rest, or the chain which slided sideward. So one is due to collision and one is this thing. So the total force due to the chain, there are two components here. 2 lambda xg due to collision and lambda xg because of the chain which is resting. That will be 3 lambda xg. Check. Most people figure out this part. I think maybe in a hurry or something, we forget this part. He never asked you find the force due to the chain due to hitting on the floor or while due to collision due to the floor. The word was find the force due to the chain on the floor. Clear? There are some chain problems. Any doubts on this? Abhinav, got it, no? Clear?
Yes, I got this.
Vidyut, Aryan, Partika, clear? Maulika, Ali, sure? Next thing. Suppose if you have a water jet. So basically the water jet hits the wall and stops. Rho is the density of the water. A is the area of cross section and V is the speed. Find the force acting on the wall. So if a water goes and hits the wall and stops, it does the exact force. And power carried by the power due to the water jet. Meaning how much power is the water jet carrying? So say power of the water jet. Let's get this. Right. Let's see. Take a thin cross section, dx. So dv will be small volume. This would be area into dx. So dm will be rho a dx. So change in momentum will be dm into v. Force will be dp by dt. Rho a dx by dt into v. Force is rho a v square. Dx by dt is velocity. So when you hit a wall with speed v, it exerts a force of rho a v square, meaning the double the speed, force becomes 4 times. Now same thing, power is also nothing but rate of change of energy. So here energy is nothing but half dm v square by dt. This would be half rho a dx by dt into v square. Half rho a v cube. This was asked in the exam once. You know, a wind is blowing with speed v, and there is a windmill which is extracting power. The power extracted is proportional to what? V square, v power 1, v cube, v power 4 ऐसा कुछ options था. So it is proportional to v cube.
So where was it asked?
Some exam revival will be asked. They will ask you. They'll ask in the exam only. Clear? It might look like, oh, water jet will exert force, big deal. It's really a big deal, you know. Whenever there's a certain thing called, you know, water cutting. I don't know whether you heard about it or not. If you take a very highly pressurized water jet, you can even cut steel. This is especially used in places, you know, where you want to cut something, but if you use a regular welding, right, it will melt the edges, and that's not a good thing. So this is how it looks. That's a highly pressured water jet, and that's your steel lock. When you see that, people get a feeling. What happens if I put my finger?
No,
It will be blown to bits. Hurt. देखो क्या करता है अभी. Now you'll see more clearly what it does. That's your steel lock. Now imagine your finger. So someone did get that an idea. What happens if you put a finger?
Every time the water jet is running,
So they didn't keep a finger, but they did make
your
a.
hand under it as fast as you can and see how bad. It's mainly this poor specimen.
So these people did create some
Yeah.
artificial finger, like, you know, materials.
But
You gave in to the primal urge. Okay, we're gonna start with a swipe.
imagine I was adjusting something on the jet and accidentally slipped and went.
Yeah.
So accidentally the hand just went
or you
through.
gave in to the primal urge and you just, you know, you risked it all.
You risked it all.
There. Just for a moment.
I wonder how that got out there, but
Well,
There. The bone would have been chipped off. You would almost lose your finger.
you'd be missing the tip of your finger,
I
as they
should get
say.
a raise. And that was quick. I mean, I just swiped that through pretty
Yeah.
fast.
So let's say you fell asleep with your hand on the water jet,
While working on
blasted
So-
back and covered the entire camera lens.
It is spraying water. You can't see the camera thing, but look at the hand. What happened there? That would have what happened to your hand. So you find a water jet. Don't put your hand. This will just cut you apart like pieces. But you can do something interesting with this also.
So this can cut diamond also.
Hmm.
So this high speed water jet can cut diamond also.
That I don't know. Re. Search it out. I don't think so. It can cut. Maybe it can cut. Kya pata? This is the waterboarding thing. You guys are able to see this? No. Did I? Oh shit! My Zoom just. I got disconnected from Zoom here. No, wait. There. That is rho AV square, and rho AV square is equal to mg. So two water jets are balancing the weight of the man. You see, you can clearly see that is that I think he must be weighing almost 80-90 kgs there. That is two people. Come wait. So this is what actually happens, when this fire station people, right? This firemen come and spray water. If you generally see two people catch the hose, if only one person catches it, he will fly off like this. But for some reason in our movies, the hero will come with two pipes with two water jets and start spraying water on everyone. So for the fire, it doesn't work. He will fly. I think that you can try in some Dubai or somewhere when you go to a ride.
So I've done this.
You have done this? Where?
Yeah. So Bali.
Bali. So there. So the rho AV squad does exert a lot of force to push this thing. Okay, take a break. Come back with 7.5. We'll continue from here. Any doubts so far? Any concepts that you didn't get? Please ask me, or else come back with 7.5. Videos, just search online. Nare sab mil jayega. You guys do a lot of googling. Ek video kya hai? Just put water jet. You will get a lot of videos. Chal, then I'll be back with 7.5. Chal, comes on everyone. I want power be rho a v square. वो 56 a different question होगा रे.
So this sum is not similar to the sum.
No, in this case, what will happen after the first collision? Na, A का velocity won't be horizontal, na. It's not the same problem. This is completely different from what we did.
Okay.
This is two oblique collisions, one after another.
Okay.
What we did was like you're colliding both at the instantaneously, so both alag hoga.
Okay.
Why won't the power be rho a v square? Because you can't use F into V. Reason, when you're hitting the wall, is the velocity constant? When you're hitting the wall, your velocity is going from V to 0, na? Velocity is changing as you're hitting the wall. It's a variable velocity. इसलिए वो half आ रहा था. Right? I think you must have taken power as F into V. That won't work. Because when you're hitting the wall, the water jet is slowing down. So it goes from V to 0. Now, the same thing, right? You can ask question like this also. What if you have a pipe like this, which is bent, and the water is entering and leaving with speed V? What is the force on this pipe? Water enters and leaves the water jet. Water enters and leaves the pipe. Somewhere in 2013 or 14, no? In Thane, there was a fire. It was an old building. So this fire station people came and started spraying water. The force was so high, the pillars broke, and the building collapsed. So luckily, no one was there. They evacuated it. The water jets have really high force. If you see, na, that's the thing. When there is a riot or something for control, what they do is they spray water guns, water cannons to disperse crowd. It is non-lethal. You don't die, but you might break 2 or 3 ribs. So that way, it hurts. So the point is to disperse the crowd that way. That was a concept. So there was an incident like this somewhere in UP or Delhi somewhere. Huge crowd, matlab almost like 1,000, 2,000 people were on a road, and there are only like 50, 60 police people. And clear tha, matlab they will not be able to stop that crowd. And the crowd is very rowdy and all, they're throwing stones and everything. So these people had only water cannons. You know what they did? Yeah, election mein, they put ink on the fingers. They took that ink, mixed it with the water, and they started spraying water on the crowd and started running away from there. They ran away. Now that ink will take almost 12 to 15 days to get removed. You can't remove it with anything. So that day night, the police people started going to each and every house, started looking at everyone. Whoever had ink, they caught them and took them to station. Why to fight with the crowd, na? Spraying. So next time when there was a riot, right? These people took the water cannon, and the crowd started running away seeing the water cannon. They're not scared of the water, they're scared of the ink. So you created a fear in them. Boss, that water touches me, and if that color gets stuck to my face, you can't remove the 15 days kuch bhi karo. These people were literally searching each and every house. That is more easy to catch, one after another. I think they arrested almost 300 people that day night. And obviously, you take them to the station, take sticks, and start beating them till the stick breaks. That is the concept. You beat them till the stick breaks. Next time, idiots will not do such nonsense things. So what are the catch here? So when you have a water jet here, see, so when the water enters, it will hit with a force of rho a v square. Similarly, when the water jet leaves, by Newton's third law, it will push the pipe back with rho a v square. You get it? When the water is entering, It is taking a turn. So the force will be rho A V square in the forward direction. When the water is leaving the pipe, it will push the pipe back with rho A V square. So we have rho A V square, rho A V square, and angle is 180 minus theta. You can use that parallelogram law of vectors. Rho A V square root over 1 square plus 1 square plus 2 into 1 into, I took out rho A V common, cos 180 minus theta. It will be rho A V square 2 into 1 minus cos theta. 1 minus cos theta is 2 sin square theta by 2. That's your answer. 1 minus cos theta can be written as 2 sin theta by 2. Yeah, Aryan, you got that. Check it out. I removed rho A V square common. A square plus B square plus 2AB cos theta. Here A and B ka magnitude is same. 1 minus cos theta is 2 sin square theta by 2. Trigonometry. Check it out. Clear? Next one. So that is how you can find the force on a pipes. 90 degrees is easy. I gave for theta. And this thing, right, you have to be very careful. House mein itna problem nahi hoga, but when you're putting a water supply to a city like Mumbai, these pipes are huge. Ever seen a water pipeline which comes into the city? There's one in Mulund. It will be huge. Huge matlab, think of like this thing. It has a diameter of 3 meters. That pipe ka diameter is 3 meters. That is almost the height of your room. That is the pipe ka diameter. Lot of water actually flows. So when they design these pipes, right, the pipeline system, you have to make sure the pipe is straight. Why two directions? When the water enters, it will push this way. When the water leaves by third law, it will push backward, right? There are two forces, entering and leaving. Water is not stopping here. So if you don't make a straight pipeline, this is what will happen. At that cross, the section where the pipe is bending, it will exert such a high force, the pipes will crack. And if the pipe cracks, it's a flood in the local area. It just puts so much water there. These things carry huge amount of water. So that's a huge momentum also. You put a lot of pressure on these pipes. You have to be very careful when you design these water pipelines. Next thing, rocket propulsion. Even though we say rocket propulsion, it's a general formula. Consider mass m moving with speed v ejects a mass dm with speed u relative to the body. I hope you know the meaning of u relative. It's the speed with respect to the new velocity, not the old velocity. So let's say we have a body of mass m here, going to velocity v here, and also assume there's an external force also. So this is before ejecting. After ejecting, this mass will become m minus dm because you throw some mass out. And remember, there's still an external force pushing it. And let this velocity become v plus dv. Because the force is pushing, maybe the speed will change. It can be positive or negative dv. And this dm particle which you throw out will have a speed of v plus dv plus u relative. This is after ejecting. The derivation is not really that important. The result is more important, but see. Now, we know F external force is equal to change in momentum by time. So here the change in momentum is final minus initial. So this will be m into m minus dm into v plus dv plus dm v plus dv plus u relative minus m into v by dt. So if you expand this, mv plus mdv minus dmv dmu relative minus mv by dt. mv will cancel. dmdv will cancel. dmv will cancel. You end up with, even though this thing looks like mu ka product role, it is quite different. I'll show you in the next thing. You end up with mdv by dt plus ur dm by dt. Even though the formula looks same, it's quite different. This is the mass at time t. This term is your acceleration of the body. This is the relative velocity with respect to the body. This dm by dt is the rate at which the mass is ejected. Quite an important thing for variable mass system. This thing looks like F is equal to mdv by dt plus v dm by dt, but be careful in that v was velocity of the body. This was u relative. This is something else. So if there is a system where mass is changing, where there is an external force also acting and mass is being thrown out, this is the thing which you have to use. Okay. So we just took initial momentum, final momentum, initial momentum, and subtracted them. We didn't do anything big logic here. Now in this formula here, if the external force is 0, then this equation becomes mdv by dt minus u relative dm by dt. This is mass into acceleration. This is called thrust force. So this is the force on the body because you are ejecting the mass. The negative indicates the force is opposite to the velocity with which you are pushing out. Means kind of obvious. If you push the gas to the left, the force will be to the right. So how do we use this? This is the second important result. Right? So whenever a rocket ejects a gas with dm by dt with speed ur, you can say this is the force. Example, let's say we have a rocket here, which is ejecting with a speed u relative, let's say 200 meters per second. And gas is ejected at a rate of 10 kgs per second. So every second you're burning 10 kgs of fuel and you're pushing out with a speed of 200 meters per second. So this gives you a thrust force. So we can write F thrust. So because of this gas going out, it generates a force of UR into dm by dt. Remember, it is gas ka speed is not with respect to ground, it is with respect to rocket, which is 200 into 10. So the gas which is going out exerts a force of 2000 newtons on the rocket, which is constant. It does not depend on mass of the rocket. It only depends on with what speed you're throwing out and with how much mass are you throwing out. This is the reason if you ever see a rocket car nozzles, right, they're designed like this. They make this part thinner. Ever played with a water tap? If you close half of the water tap, the water comes out faster. So by making the nozzle thinner, you are making the gas come out faster. So basically you're increasing UR. But there's a problem. If you make it too small, the mass that is coming out will decrease. So there's a particular value where you get maximum speed also and maximum mass also, the product. So the nozzle has to be designed in such a way to produce maximum thrust. Have a look at this. This is how rocket propulsion question. So main thing you need to know is this one. So whenever the gas is ejected of a rocket, it will exert a force of UR into dm by dt. Let's see a problem on that. I think you'll get a better idea. Let's see. So let's say we have a rocket mass 2000 kgs. This is a rocket plus fuel. This thing is placed on the ground. This ejects. At a rate of 30 kgs per second. With a speed of 500 meters per second relative to the rocket. So the question is, find the time when rocket lifts off. So maybe someone overloaded the rocket actually. Find acceleration of the rocket, gravity is there. Previous page. Yeah, I'll show you. Find the acceleration of the rocket at t is equal to 20 seconds. Let's get this. Initially, rocket is at rest. The first thing, so F thrust is U R T M by dt. So this thing is 500 into 30. So this guy is actually generating 15,000 newtons. But the problem, the rocket ka weight is 2,000 kgs, that is 20,000 newtons. So the rocket lifts off when F thrust becomes equal to mg. That means m should become 1500 kgs. Therefore, you have to burn 500 kgs of fuel. Therefore, the time will be 500 kgs by 30 kgs per second. That is 50 by 3 seconds. Perfect. Next thing, you want the acceleration at 20 seconds. At 20 seconds, remember the thrust force will not change. Thrust force is still same, 15,000 only. But the weight has become m is equal to m minus how much? 30 into time. That is 2000 minus 30 into 20 is 1400 kgs. So this is 14,000 newtons. And it is acceleration. So we can say 15,000 minus 14,000 is equal to 1400 A. The A will be 5 by 7 meter per second square. Check it out. Thousand by 1400, na? So this is one type of problems. The main thing here is mass is changing. Thrust force will remain same. F thrust minus mg is equal to ma. Clear, everyone? Neil, clear with this? Palaksh, Ali? Clear? Udayan? Vartika, got this? Rehan? Abhinav? Perfect. Next one. Turn in the page. Any doubts on this? So that's it. So main thing, when you see a rocket propulsion, just put an F thrust force and the mass keeps changing. Let's see a better version of this. We have a rocket. M is the mass of rocket plus fuel. The gas is ejected at a rate of lambda kgs per second. With speed u relative to the rocket. To assume the vehicle, this thing, lifts off immediately. Find the velocity as function of time t. Meaning the thrust force is strong enough to lift off immediately.
So what do we have to find again?
Find velocity as function of time t.
Okay.
Gravity is there. Find velocity of the rocket at time t. u lambda t by m near है. You have to integrate. Not much is understood. FBD. The thrust force is lambda into ur. Your weight is mg. And acceleration. So once you write the thrust force, you can just use the regular F is equal to ma stuff. F thrust minus mg is equal to ma. The F thrust will be u into lambda. This would be m minus lambda t into g is equal to m minus lambda t into a. So what we did was when we derived that F external is equal to the two components, we got the thrust force from there. So when you include F thrust force, the variable mass system thing is taken care of. So we have acceleration will be u lambda by m minus lambda t minus g. A is dv by dt. So dv will be u lambda integral dt by m minus lambda t minus g dt. This will go from 0 to v and that will go from 0 to t. Now in case you forgot the integration, dx by ax plus b ka integral will be 1 by a ln ax plus b. So this will be u lambda minus 1 by lambda ln m minus lambda t from 0 to t. Substitute this thing. There, this is the velocity as function of time t. Suppose if gravity was 0, suppose this engine was started in a gravity-free space, F thrust force is lambda dx by dt, dm by dt. Re. Dm by dt is what? Rate of change of mass, right? So here mass is changing at what rate? Lambda kgs per second. It is u into dm by dt. If rocket is in gravity-free space, then g ka term will be 0. Then we get velocity of the rocket will be u into ln m minus lambda t. So the final velocity of the rocket will be u relative ln the final velocity will be when the rocket ka fuel gets over. So that would be mass of rocket plus fuel by mass of rocket. Basically mass initial by mass final. That's why when you design a rocket, right, you make sure, for example, if the entire rocket is 1000 kgs, the actual payload is only 100 kgs, remaining 900 kgs is fuel only. So the bigger that ratio, the higher the final velocity of the rocket. So this also they can be asked. A rocket is in a gravity-free space. Half of the rocket is filled with fuel. Find the final velocity of the rocket. If you know this directly, you can put it there. So that will be ur ln 2. Check it out. Clear? Any doubts on this? Clear? Next one. Can I turn the page? We have a trolley here. Someone is pulling with a constant force. Initially at rest. There's a lot of sand on top of this trolley. And there was a small hole here, and the sand starts leaking here. One is the mass of the trolley plus sand. Find the velocity of the trolley at time t. If the mass was constant, your life was easy. F is equal to ma and b is equal to u plus at. Mass is changing, so you have gone. First of all, acceleration is not constant. This is easy. See. Let's get back to the basic equation. Whenever mass changes, remember the general equation which I taught you. Now there's an external force also. This was a general equation. F external is m dv by dt plus u relative dm by dt. Now in this scenario, u relative is 0. Why? If the trolley is going with v, won't the sand also fall with v? When a particle leaves the moving system, it will have the same speed as the moving vehicle, right? So velocity of the sand with respect to the trolley is always 0. Since sand has the same velocity, the speed of the trolley is changing, but the sand also at that instant will have the same speed. Sand has the same velocity as the trolley when it leaves or when it drops. So basically the second term is 0. So f is equal to m minus lambda t into dv by dt. You get the answer in one step. मतलब you have to integrate though. So dv is equal to f dt by m minus lambda t integral. Check. That's the velocity of the trolley as function of time t. The cart will fly off at an angle. Why will it fly off at an angle? You're saying you'll get a rocket off. See, if the sand goes like this, so thrust force will be this way. That's what you're saying. The sand is just dropping, right? This is not you're not pushing out with any speed here.
So we
If it was a booster though, right, it will fly off. They're not doing that case.
so
Abhinav.
so we can leave the unsigned form of ln, or we have to further calculate.
नहीं बस इतना ही है.
Okay.
Normally, even in advance, answers will be like that only. Ln 3, ln 5, ln 5 by 7. They won't ask you to simplify. They won't give you a log table. You can't solve. Clear, everyone? Last one. Gravity-free space. We have a rocket, which is going with speed v, and m is the mass of the rocket plus fuel. I'll just say initial mass of the rocket. So it means rocket plus fuel. Now this rocket, right, v is the initial velocity. So it was just going straight. Common phenomena whenever you have these rockets and satellites. So sometimes, right, they need to make an adjustment. They want to make it go in different trajectories. So you have something called a side thrusters. So this is a main thruster, which will change the speed, but you have a side thruster. So this side thruster ejects gas at lambda kgs per second with speed u relative to the rocket. Now, because of this, what will happen? The rocket won't go in a straight line. It will start bending. This is what actually happens in satellites, the course correction. This is one of the main reasons why you have to keep launching new satellites every 3-4 years. What happens, right? Even though we say space is vacuum, in reality, there's a thin atmosphere. So the rockets in the space, right, they actually keep deviating the path. So they have some fuel on the satellite in order to keep the adjustments. And generally, that fuel gets over in 2 years. And once the fuel gets over, it is very expensive to go and refuel it. It's a better way to launch a new satellite is cheaper. So that last amount of fuel which is left over, what they do, they direct the rockets towards the Earth and they crash these satellites in Pacific Ocean. Because leaving the satellite there is pretty dangerous. It will create debris and it might go and hit some other satellite. So the common policy is to crash the satellite and it ends up its life. And if you go and search in Google, there is a map also. There is a location called the graveyard of satellites. It is the farthest point on the Earth from any known land. Matlab, it is the farthest point from any land nearby. So they go and crash it there. Rudders, it's too thin atmosphere, right? It is not a plane to glide. It's an air resistance. So the rocket will actually bend. So deviating by delta. So because due to side thrusters, the rocket deviates. Find delta as function of time t. By what angle will this rocket deviate? Due to side thrusters. So country like China, what they do, they say anyway satellite ko girana hai, so what they do is they use it for missile testing. They launch a missile into the satellite and they destroy their own satellite to scare America, like, dekho, we can actually destroy our satellites anytime. That's the warning. Interestingly, India did something like that recently last year. It was a big mess. Some of these particles flew into the trajectory of other satellites, and there was a big issue, like, the other satellites will get damaged and all. As usual, the rocket deviates. Find delta, the angle of deviation as function of time t. Question could be like this: find the time when the rocket makes a 180-degree turn, meaning you keep on thruster, it becomes like this 180 degree. And remember, this thrust force is always perpendicular. Huh? The thrusters eject gas perpendicular to the velocity. Let's get this. Electricity is generally not the problem. We have solar panels, so we get enough electricity for them to run forever. Problem is the fuel gets over. Vinod.
So when the satellite is separating, the force exerted, is it calculated in a similar way?
When the rocket is coming in,
So when that rocket, like when we launch rockets for satellites, when it's separating, that force exerted just for the separation, is it calculated in a similar way as we calculate for fuel?
wo alag hai re.
Okay.
When they separate out, there are, like, small explosives kind of thing which will push away each other.
Okay.
That's like an impulse. You just kicked it for a moment. There is no thrust there.
Okay.
Or think of like that sand problem we did now.
Yeah.
It is just like dropping a sand. So what we are doing is basically reducing your mass so that remaining fuel can be used to accelerate much faster. You're accelerating a lower mass now. Why you want to carry the dead weight? Once the thrusters ka fuel gets over, we keep separating them to lower the overall mass.
Okay.
If you see this main rocket, the launch, right? The rocket thing is full like this. The actual part is only this much. We have side boosters and everything. One after another, everything will just keep falling down. Very expensive. Launching things into the space is very expensive. That's the problem why any space program has issues. Fuel is the most expensive thing. Somehow, if we can find a fuel which is cheaper, space travel will be much cheaper. Because you need a fuel which has less density, less mass, but it should have more power to generate more power. Such kind of fuels are expensive. Now, this is a little weird one, but in this entire question, what word catches your mind when you see this thing? It is always that way. Huh? See, I'm telling you again, when you solve questions, right, don't just jump into the concepts. When you see the question, you will see some words. And that words mean something. If you can figure out that, you'll get an idea what to do. Right, Anika, that is the word. So what? Fine. So it caught your this thing. So what next? Adrit का अलग ही concept है. Is the answer long or short? मैं पूछ रहा हूँ concept क्या है, तुम बोल रहे हो आंसर बड़ा है छोटा है. Adrit. चले काम करते हैं. Try this as a homework problem and come next class discuss करते. It's a good one.
Is the word side thruster?
Side gravity नहीं है. Gravity free space लेगा ना.
Okay.
This is in space. There's no gravity there. So finish off. This is the last one for the day. Try this and come. Next class, first thing when we will discuss this. And then we'll start off with rotational mechanics in the next class. Right. So with this, we are done with center of mass and collision. So almost 57 problems. So check it out. So the word which you have to look at is this word. So try this and let me know next class what to do from here. Think about it. It's a good one. Okay. Sure. So any doubts, anything, stay back and ask. Also free to leave. I'll see you guys again next week on Wednesday as usual.
Bye, sir. Thank you.
Bye, Ray. Take care.